So when was the last time that you cut your finger and lost your hand? Or maybe you grazed your knee, and the result was that you had to have your leg amputated. Fortunately, most of us don't have to worry about this thanks to the discovery of antibiotics. But a terrifying future looms on the horizon, the one in which the antibiotics that we've begun to take for granted no longer work. And this isn't some faraway problem that's not affecting us, and it's not affecting us now. As a pharmacist who used to work in a hospital in Bristol, I can tell you, we saw examples of antimicrobial resistance every single day. So what do we do? Well, I'm not going to stand here and tell you that there's one magical bullet, because there's not. But one thing we definitely need for patients right now is new antibiotics. And where do we find these antibiotics? Where do the antibiotics that we use in the hospital now come from? Well, the vast majority of them come from a bacteria or fungus producing something to kill another bacteria or fungus. But we begin to find the same old antibiotics again and again. So we need new bacteria. We need bacteria that we've never seen before. We need bacteria that no one has ever seen before. Bacteria that live in such extreme conditions, they do things modern chemistry just didn't think was possible. Where am I talking about? I'm talking about the deep sea, the abyss, a place where today we know less about it than the surface of the moon. And where am I looking in the abyss? Where do you even start in the blackness of the abyss? Well, I'm looking at sea sponges. And sea sponges are actually quite interesting animals, mainly because they're the oldest animal. For 580 million years, sea sponges have existed on this planet, and for every single one of those 580 million years, the bacteria that have lived on them have co-evolved with them through time and have a vested interest in protecting their home, the sponge, from other bacteria that would do it harm. And at Bristol, we've got almost 300 of these deep sea sponge samples, some of them from 4.5 kilometers deep in the black of the Atlantic. And we're growing these bacteria in the lab. Bacteria that have never seen the light of day before. Bacteria that have never been seen by a human eye before. And we're testing them against superbugs that are plaguing our hospitals. Superbugs like MRSA. And what we're looking for is a zone of clearance, much like the one around this deep sea bacteria here. And that tells us we might have found the world's next new antibiotic. Often, with antimicrobial resistance, it can seem like we're standing on the edge of the abyss. What I'm hoping my research will show is actually that's exactly where we should be. Thank you for listening.